Hey scholars, this is Mr. I with you. Once again, we're working on our test corrections. Now this one is problem number 8, which is asking you to find the sum of 8 plus 16 plus 32 plus ... plus 512. So as you can see, this is a finite sequence because notice it has a starting point and it has a specific ending point. And it wants us to find the sum. Remember, we have two types of sequences that we're working with. It's either geometric or arithmetic, as I say. So let's figure out what this one is. Well, let's look at our first terms. If you look at our first term right here is 8. Our second term is 16. So if we subtract 16 minus 8, that gives me 8. And then I'm like, okay, so that's 8. And then I go 32 minus 16, and I'm like, whoa, wait a minute, that's not 8, right? No, so we know this is not arithmetic. So now you got to check it because it might be geometric then. So 16 divided by 8, so let's see, so we're looking for R. So we're saying 16 divided by 8 is, hey, that's 2. Oh, okay. And then let's check the third and the second just to make sure. 32 divided by 16, right? So let's see. 32 over 16, and that gives you 2. Oh, cool. So that means this must be a geometric sequence. And it's not just any geometric sequence, it's a finite geometric sequence. And we want to know the sum. Okay, well there's the formula for that. In your packet, you have the following formula. S of n, which means the sum of n terms, whichever terms we want, right? Right now I'm just going to plug in the formula and then we'll talk about what n is and all that stuff. So this is going to be a sub 1, which is your first term, times 1 minus r, which is your common ratio, which we know is 2, but as I said, I'm not going to plug it in yet. First I want to write the formula out. To the nth power, which means to the power of whatever terms we're looking for, all over 1 minus r, which is your common ratio. So now that we have the formula, let's go ahead and take our information and plug it in and see where this takes us. So here we go. S of n, because notice that you're saying, well, wait a minute, why don't you put in how many terms we have? Well, the problem here is that, do I know which term this is? I don't know. So I don't know what n is yet, right? So let's plug everything in and then we'll go from there. So we get a sub 1, which is my first term, 8 times 1 minus r. Well, r, I do know. R is 2. So we plug in 2 to the nth power because, like I said, I still don't know which term this is. I know the value of that term is 512, but I don't know which term is it. This is a sub 1. The value is 8. This is a sub 1, which is the first term. This is a sub 2. The value of a sub 2, or my second term, is 16. You see? So this is 512. That's the value of my last term, but I don't know which term is it. That's what I'm talking about on that, okay? So you do not, I repeat, you do not put 512 there, okay? All over 1 minus r. R, which was, we said, was 2, right? So now, we have this problem then that we have noticed that we have everything we need except for this guy right here, the n. We don't know what n is. So this presents a small situation. It's not too difficult where we need to use a different formula, the formula for the nth term, to actually find our value of n, or which term this is. So let's go ahead and do that. So as you recall also from your IB packet, we have this formula. A sub n equals a1 times r to the n minus 1. This is the formula for the nth term of a geometric sequence. Remember, this gives you any term in your sequence. Okay, this is the generic formula or the generator that gives you whichever term you want to know. So let's plug everything in and see what we have. So a sub n is basically whichever term I'm looking for. Now, in this case, I know the value of the a sub n term, which in this case I know is 512. Okay, so I'm going to go ahead and plug in 512 here because now I don't know n, but I know the value of my last term is 512. So here we go. And a sub 1 is 8, r is 2, but what I don't know is n. In other words, I don't know which term this is. So I have n minus 1. Okay? So now all we're going to have to do is we're going to do a little bit of guess and check here, and we're going to figure out what does n have to be in order for these, right? In order for this side to be equal to that side. So let's do a little bit of simplification first. let's go ahead and, to make this a little easier to work with, divide both sides by 8. So this guy goes away. So we end up with 512 divided by 8, which actually is 64. So we end up with 64 equals 2 to the n minus 1 power. Now, there's different ways you can do it. We have been doing logs and exponentials, so we could take that route with this, or we could just take the guess and check route. So I'm just going to do the guess and check route. It doesn't really matter how you do it. Both ways are going to work. So if we do the guess and check route, this is actually, let's plug in some numbers and see what we get. If I plug in, for example, a 5 ren, right? This will be 5 minus 1, which is 4 to the second power. Now, I know already that number is going to be too low. That's only 16. So then we need to pick a higher number. So I'm going to say, well, you know what? I'm going to try 2 to the 6th power. And guess what? When I did 2 to the 6th power, this actually works. But remember, you want 2 to be a 6, right? 2 to the 6th power. So what am I going to plug in for n? I'm not going to plug in 6, because if I plug in a 6, 6 minus 1 is 5. So that will be 2 to the 5th. So what I'm going to plug in for n is actually going to be 7. Because if I plug in a 7 here, that gives me 7 minus 1, which is 6 to the second power. Boom, that gives you 64. So I know n is 7. So if I come over here to my equation then, I already know. Hey, you know what? 512 is actually my 7th term. Cool. So then this is actually S of 7. So I want the sum of the first 7 terms because this was my 7th term. So I go over here and I say, hey, this guy is a 7 right there. So now we're in great shape. We're going to plug it in and boom, we're going to be done. So let's see. It sounds like that cook guy on the TV. Never mind. So we got 1 minus 2 to the 7th power. Boom, that gives you negative 127. So, but remember, we're going to divide. This gives you negative 127 over 1 minus 2. If you do everything in the calculator, guys, be careful. Put this in parentheses. A lot of you didn't, and then it gives you the wrong answer. Okay? So, over, basically, this actually is just negative 1, right? So, this gives you a positive 127. And you're going to multiply that by this number that's outside, which is 8. So, you end up getting 127 times 8, which gives you a grand total of 1,016. So what happened in this problem is the sum of the first, like we said, ended up being 7 terms in this sequence. Ended up being 7. We didn't know, but we found out the first 7 terms is 1,016.